So, in math, we don't really have much direction. We love saying that the table is 4 meters away, but that isn't really useful, since is it behind you, in front of you, or above you, or even a mix of them? Thankfully, people have thought about this before us and created a thing called a vector. In notation, it looks really similar to a coordinate, but on its side. And when a variable is a vector, we put a little arrow over it to make it clear. You can notice there are 3 numbers, each representing how much we are moving in each of the 3 directions, x, y, or z. Here is a vector moving just to show you. Now, the next logical thing to ask is if I have 2 vectors, can I add or subtract them from each other? And the answer is yes, and it's easy actually. You just add the terms across from each other, like here, where we add vector A with vector B and get this new vector, which is 283. Or we can subtract B from A and get this vector 6 minus 4 minus 5. Here I'll show the vectors A in red, B in blue, their sum in purple, and A minus B in green. Now, there are 3 ways to multiply vectors. I'll start with the simplest, which is multiplying by a scalar. A scalar is just a regular number, like 3 or 21, and when we multiply a vector by it, we just multiply each component by the scalar. So here it goes from 333 to 999 after we multiply it by 3. Now, this is closely tied to magnitude, which is denoted by having these 2 lines around the vector. It denotes how long the vector is. For example, if we have this vector 1, 2, 3 and we want its magnitude, we use this formula, which is just Pythagoras in 3D, to get the square root of 14. Now, here is a vector being scaled with its magnitude shown. Now, the next kind of multiplication is called a dot product, and this is between 2 vectors. We denote it with, you guessed it, a dot between the 2 vectors. Now, how we get the dot product is we multiply across, so a1 by b1, a2 by b2, and a3 by b3, and then we add them together. We end up with a scalar quantity or just a number. Let's take these 2 vectors as an example, 135 and 246. We take the dot product and get 2 plus 12 plus 30, or 44. Now, this result can tell us a fair bit about the 2 vectors. If the result is positive, it means the angle between the 2 vectors is acute, while if it is negative, the angle is obtuse, and if it is 0, they are at a right angle. I'll show here 2 vectors moving with their dot product. Now, the last kind of multiplication is called the cross product, and we denote it with a cross. It answers a very important question. If I have 2 vectors, what is the third vector, which is perpendicular to both? Unfortunately, there isn't an easy answer, but there is a formula, and here it is. I know it doesn't look all that elegant, but it gets the job done. Here are 2 vectors in blue and red, and their cross product in purple. So that's how vectors let us point with math. If you enjoyed the video, please like and subscribe. I hope you learned something new, and have a nice day.